Hello everyone. In this lesson we are going to review over all of the different forms of quadratic equations, look at the kind of information, review over what we know about the kind of information that's easily available in each of them and how to work with each of them and methods of converting between them. So big old review lesson and a little bit of new, but mostly review. So for this lesson, if you want to follow along, take notes and really help yourself learn it. Pages 8 to 10 in this file. So like 7, 8, 9, actually, I should switch that. So 7, 8, 9. Got rid of one of the pages earlier. 7 to 9 would be what you could use as a template to follow along and learn as you go, like you would in an in-person class. And then, of course, page 1 is your practice assignment to submit. So here we go. Our standard form, vertex form, and factored form. Those are all of the different forms we have talked about. And so just as a review of what you can tell from each of these, you might remember that this number right here is special, and that number there is special. So the A value, I'll color code this, but the A, of course, gives what? Well, that gives the shape of the curve, like the house, how quickly it gets tall, either up or down, and the positive or negative gives the direction of opening as well. So I should add on to that one actually. Plus large number makes it tall and skinny, and 0 decimal number, small 0 decimal number makes it be wide. Okay, so just add a bit of information there that I forgot to put when I was crafting the lesson, putting the lesson together. And of course, positive, it opens up, and negative, it opens down. And the C value, you might remember, if you plug in zeros everywhere, so let's go blue for this one. C, we plug in 0 and 0 and so on, we're really getting the y-intercept. Okay, so C is the y-intercept. Of course, the idea that's pretty logical, right? Where you're looking at this curve and you're saying, okay, if we're putting in an x value of 0, that would mean that I'm looking at this spot, right, where x is 0. And so then the graph is going to tell you where on the axis the curve lands, right? And so it's giving you the y-intercept I was trying to go for there. So that's the standard form, what we can tell from it. Trying to decide whether I'll keep going with the standard form. Let's go across the page sideways here so we can compare what we can tell from each of them. And then continue on with the next page is going to be processes we know, that we work with and use. And then the last one's to do with converting between forms. So vertex form, this one here, we know that the A value, once again, gives us the direction of opening, the positive is up, the negative is down, all that same stuff. And even this positive, plus, not positive, but, and also, right, a large number makes it tall and skinny, whereas a 0 decimal number makes it wide. It looks wide, it's really actually squished vertically, right? So exact same stuff as the previous one. In this one, though, we don't have a C value that can give us the y-intercept. Instead, we have other values in here. So the P, for example, here, so let's use green for that one. The P value tells you how far it's shifted left or right. Right? So that's your horizontal shift. And that's the one where, remember, that it's inside the bracket, so it's weird, it's backwards. Okay? So that means that a negative would mean it shifts to the right, and positive means it shifts to the left. And the Q value on the end, way out here, so let's go blue for that one. The Q value, P value, those aren't negatives, those are just like dashes for the bullet points, whatever. Push that up. I don't like using the bullet lists in the program though, because it starts to try and format everything on me. Anyway, so Q gives the vertical shift, right? And so it's the normal stuff. And negative in this case means down, and positive means up. Okay, so that's the information you know from vertex form. Or supposed to know by now, should know by now, hope you know by now, whatever. Factored form. So for factored form, that A value is the same stuff again. Right? If there's an A out front, or if there isn't, it's just understood to be a 1. Either way, it's still the same information. A 1 would be original shape and so on. So just basically ditto, 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 same stuff. Okay? The A value is visible all the time, either as a 1 or as a number that's more visible, like a 3 or a 4 or whatever. And then the other part that's visible here are these numbers give you your x-intercepts or your zeros. Okay, so S and T, those numbers in there, they give you your x-intercepts or your zeros. And of course, it's brackets backwards still, right? So, yeah. So x-intercepts or zeros. Either way, we know it's where the thing crosses the x-axis, right? And so that number there and that number there. So if we had something like that was x plus 2, it would be at -2, and looks like put that one at about 3, and so that would have been an x minus 3 factor. Would have given that, just as a for instance. Okay, so that's what you can tell from each of the forms. Moving on to, and press pause or fast forward or slow, whichever you need for your pace through the lesson. The processes we know, processes, I guess I should have said, but process we know for each one. It makes sense if you think them one by one. We can make a table of values. So again, just to remind you, we're talking about the standard form, right? So we can make a table of values and graph the thing point by point, right? So we can calculate the numbers, we can plot the points and graph the quadratic. And then from that, we can identify key values, the maximum, minimum, the vertex, the x-intercept, the y-intercept. Some of these are going to be estimates, right? So, possibly just estimates, or if we get lucky, right? So estimates, depending on where the numbers ended up. Sometimes you nail the vertex and you can tell, or you nail the x-intercept, but best you can expect as a for sure would be estimates for a lot of that. So there's an example there we can work out quick here. We can look at our usual stuff. So if we put in a 0, then we know we're going to get the -3. If we put in a 1, I'll just do a little bit of calculations down here. So y equals the x squared minus the 2x minus the 3. For plugging in a 1, we get 1 squared is 1. -2 times 1 is -2, -3. So I have -5 plus 1, which gives us a -4. Put in a 2. 2 squared is 4. -2 times 2 is -4. So those are gone. And we have a -3. So it's going to be -3. And it's kind of nice when you see that repetition starting already, because you can tell that's your axis of symmetry. So let's go one more this way. 3 squared is 9. 6 times 3, 2 times 3 is -6. And then the -3. You can tell here you've got -9 and 9, so it's a 0. And it could go farther either way too, but let's go -1. Oh, get rid of that. -1 would be a 1, be a +2 this time, and a -3. So we've got a 3 and a -3, so it's 0 as well, and so on. And so if I do calculate, another number this way, I'd be able to see that it would just repeat on either side, of course, right? So let's do one more. Let's do the -2. -2 squared is 4. -2 times -2 is +4. Then -3, we get 8 minus 3 is a 5. So that's going to be a 5, which means this is going to be a 5 also, and so on. That's plenty to make a good graph of this thing. We've got our 1, -4 right there. Got our 2, -3. We've got our 3, 0. And our 4, 5 right there. So then the mirror image stuff here, not there. Sorry, I just got off trying to touch the smartboard here. It didn't work out. This one here should have been there, right, or there. There we go. So I was trying to do by mirror image and botched it because the y-axis kind of got in the way of my process here, but 0, -3 is where exactly where that point is. And then -1 up nothing right there, and back to up 5. And you can still see the mirror image situations going on there, right? So that is our graph. That's to make it nicer. And obviously then you could tell here you've got the vertex, which we could tell from here anyways was the 1, -4. Means that's a minimum of y equals -4. We've got our axis of symmetry. X equals 1. We've got our zeros of, that's a negative. I just have to be careful here where I put that as -1. So zeros are x-intercepts of -1 and 3. Which you can see here as well, right? Your x-intercepts of -1. I missed my circle here. But when I put the y value of 0, I get the -1 and the 3. So those are x-intercepts. And so on. Okay, so there's an example we're through of the process to do with the standard form. Let's go with what we know how to do for vertex form. Obviously, we know we can graph the thing easily by graphing the original shape, and then we can graph the transformations one by one. And so let's go with an example like this. So we have this one, you could say, okay, I know it's stretched vertically by a factor of 2. So, you know, I might have that stuff down here. No, I don't. So it's going to be stretched vertically by a factor of 2. I'm going to say vertical stretch by 2. It's going to be moved left. Be careful there. Left. So I'm going to emphasize left 3. And I'm just going to be going in orange here, down 4. So I don't have the tables in this slide worked out, but I do have the picture just kind of already drawn here. I probably should just do it from scratch, but let's just talk it through here. We've got the original one that's over 1 up 1, or the blue one, the over 1 up 1 right there, and then over 2 up 4 and so on, the regular graph. And then you can see it's like up twice as tall and so on, right? So over 1 up 2 and over 4 up 8 and so on. So there's your twice as tall one, and then it's shifted left 3, down 4. Purple one in the end is the overall result. Okay. Go back to the lessons on that if you need more detail, you know, step by step of that thing. I guess I could do the table here too, easily enough. -2, -1, 0, 1, 2. X and y equals x squared. We have our 4, 1, 0, 1, 4. And then our transformed one, so let's do the green version of things. We're still going to have our same numbers, but we're going to be twice as tall, right? So multiply by 2 gives 8. Multiply by 2 gives 2, 0, 2, and 8. So that's the graph of the green one. Then the red one would have been if we shifted left. Sometimes do that one last, but y equals 2x squared here. Sorry, it's a little sloppy. I'm just trying to review the ideas here. Y equals the 2, and then we have the x plus 3 squared. So just like saying, oh, it's actually to the left 3, we're going to actually subtract 3 from everything. Just move down a bit so I can do a better job there. subtracting 3, whereas here, of course, in green, we multiplied by 2, right? So when we subtract 3 along the way, we get, what, a -1, a -2, and a -3, -4, -5, which is where our points would have been graphed. So that's the same y values. And then the final one I did as orange in my description. So I'll go orange on the table. We've got our x and our y. We're going to keep those same x values. And now we're going to, what are we doing? Down 4. So down 4 would be to 4, and down 4 would be to -2, and down 4 would be to, from this one, down to -4, and down 4 to -1, and down 4 to 4. Looks like something's wrong there. Down 4, down 4. 8. This number, one of them's wrong here. So multiplied by 8, 2 and 2. So these are both 2's. Down 4 is -2. Well, down 4. Hard to get back on track once you mess up here. So down 4 from the 8 was 4, down 4, -2, down 4, negative. This one is also a 2. It just didn't look like it. So that's a -2, and then the 4. So we got our repeating numbers again. All right, saved it, I think. Here we go. So keeping going, just to remind what we're talking about for this one, we're looking at the factored form. Okay, so in an example of that, we could use the zeros to get the axis of symmetry. We could get that, plug in that axis of symmetry, which we do the midpoint obviously to get, and then we plug that number in to get the vertex itself. So in an example given here, where we have x minus 3 and x plus 3, we have zeros of 3 and -3, which of course you could just put dots on a graph easily enough. Midpoint of that is actually 0. 3 plus -3 gives 0, divided by 2 is 0. And then if we plugged in the 0 value, we calculate out, get a -9. So if you put that all on a graph, it looks like this. You'd have your 3 and -3 zeros right here and here, so -3 and 3. Circle them for you. And then the axis of symmetry is at 0, right along the axis, and then the -9. So you can graph them all. Okay, so that's that. What we do with them directly. Then the other thing we want to talk about is switching between forms, which we've done a little bit of lately, right? So to switch, what can we do with a standard form? Well, we can factor it, right? We can factor to convert to something like that, and then we'd be able to know the zeros from that. Okay, so an example of that one that we can follow through here is the same one we just graphed, right? The x squared minus 2x minus 3. If we were to factor this, we'd look for n numbers, factors of the n numbers, 1 and 1, and 3 and 1. We know there needs to be a negative somewhere. We're going to wait and put it where it needs to be. We're going to multiply straight across. We're going to get a 3 and a 1. We want a -2, which means we want that negative to be, we're going to have a -2. So finally, that negative we know needed to go somewhere. We know where it needs to go. So when we do this, we fill in our 1x and our 1x, and then the first one has to multiply on a -3. So it doesn't actually matter in this case, but kind of be a good habit to be in, right? So, just put it in the right spot. That way, when it matters, it'll be in the right spot. So we got our -3 and our 1. Oops, got my colors mixed up when I. Let's do that. I'll just put the orange over top of this one. So the -3 based on. Oof, it's killing me with colors here. All right, so we got the -3 goes in there, and then the 1 here. All right, so that's the factors, and then of course the zeros are obvious, where you tell like, oh, the zeros are, right, if I set this equal to 0, then we'd have zeros of -1 and 3, which if you look at our graph is what we had, -1 and 3. Okay. And so on. And obviously we looked at up here, we could do more, right? We could get the vertex and so on, but the stuff that we generally did to get started, and the rest of it you can continue on. So once you have those zeros, like I said, we just had done this where we had the midpoint and then the vertex, we could do that too, in which case that would have also confirmed, this vertex of 1, -4. I don't want to do like everything in every case, but just want to point out that we could. And then vertex form here, then that's, of course, what we can do with that is we can multiply it all out, and that would convert to standard form. If we did that, we'd be able to tell what the y-intercept would be, right? Just have to ungroup that thing. Just ungroup. There we go. So that would allow us to figure out the y-intercept if we did that. And we could also possibly factor if it's factorable, and that would give us the zeros. Okay. So the example we had here, let me just write that out. Just take that onto our next page. So let's see if, not everything's factorable, but I'm pretty sure I made this one, so it would be. So we'd have our 2 out front, we'd do the x plus 3 squared. So it's kind of nice if we just show it like that. And so we need to do the x times the x, which gives an x squared, the x times the 3, which gives a 3x, 3 times the x, which gives another 3x, and a 3 times a 3, which gives a 9. Got that result. We know the 2 is in front of all that stuff because it was in front of the whole thing anyways, right? This thing is this stuff, right? So the 2 is in front of all of it, just like before. And so then we multiply out, we have 2x squareds. In the middle, we have 6x. So I'm just going to jump to say, okay, 2 of those, so 12x. 2 of the 9 is 18. Take away the 4. So we get 2x squared plus 12x and plus 14. Okay. So we got to standard form. And then if we wanted to factor this thing, we graph that thing. It's supposed to have a y-intercept of 14. So go back to this picture here and picture this thing going way up to a y-intercept of 14. But that's from the 3rd page or whatever, right? Basically, we can tell what that y-intercept would have been because of our math abilities rather than just drawing it. And then the next step here would be to notice that we have a common factor to make our lives easier. So we can pull out that common factor. X squared plus the 6x plus the 7. And again, if any of these processes you're confused, that's as good. That's the point of this lesson. But make sure you can see which processes you're comfortable with. Go back to the common factoring lesson if you need help with that, right? At this point, we could factor this thing by using the 1 and the 7. And we're looking for if it's factorable. I thought I had made it factorable. No. I need a minus somewhere. Did I miss a minus somewhere? -4. Yeah, it looks like that one's just not factorable, I don't think, because factors of 1 and 1, 7 is a prime number, so 7 and 1. So it's like you'd have to have one of them be a subtract. So I might have messed up that one and that made it not factorable. In your example, your practice questions, I believe this one, when you do it, it ends up being factorable. So I botched that one, I think. In this case, obviously, we could multiply it out to convert to standard form as well. So if we did that, we'd also see the y-intercept. There is a process. It says in sort of gray there. It's back here. Right, the y-intercept would be obvious as well. There's a process for converting to vertex form. It's called completing the square. We're just not doing it in this course. That's pretty much it for quadratics for us. All right. So again, here, if this had have been factorable, then of course the zeros would have been obvious as well. I feel like maybe I've made a mistake and it actually is, but what are know if we have zeros obvious on the graph here. Yeah, see how it's kind of skipped? So I think I might have made it a non-factorable equation because these zeros don't appear like they're landing in an exact spot. Otherwise, I would have had zeros along the way. So somewhere in between here and here, there's a zero, which means somewhere between -2 and -1, and somewhere between the -4 and -5 be where the zeros would be. So because they're somewhere between, that means the numbers are kind of more complicated and not easily factorable. All right. So that is the stuff. It's a good overall picture of what we have accomplished. Hopefully you're comfortable with that. If not, post some questions. I can help with individual pieces of it. Yeah. So that's the practice page for that. And then I'm going to put a submission, like a submit for marks assignment up once you've had a chance to get feedback on this. All right. All right. There we go. All for now. That's all for now.